Hey guys, today's problem is search insert position, and this is simple searching question where we have one integer array. It is sorted. So um, from 1 to 6 it is given in sorted array sorted manner, and we have one target variable, and we need to return its position, right? Where can we insert it in this sorted array? And we need to write this algorithm in big O of log n runtime complexity. So this is simple question of binary search algorithm, and binary search is one of the algorithm which you should know by heart, and it is very helpful. In many cases we'll use binary search algorithm, and for the binary search algorithm the question can be asked in multiple ways. So this is very helpful algorithm, and uh, whenever we use binary search algorithm, the runtime complexity will be big of log n, because always we are if you know how we are using binary search algorithm, it's like 1 2 3 4 5 6. Suppose this is our array or input. So what we are doing is, in each iteration we are taking half of this input and searching our element. So suppose in the first iteration we have this whole input, but in the next iteration we will take maybe right or left half part of this input. So in the next step we will have 4 5 6, and again in the next step we might have 5 6, and in the next step we might find 5, right? So this is possible, and that's why we have big of log n, because every time we are uh, dividing the input in two parts and then searching in it. Okay, let's check the companies: Facebook, Apple, Amazon, Bloomberg, VMware. So not lots of company, but maybe because they are asking other questions which includes binary search. But it is as far as my experience is, in many other questions we might see the same algorithm. Okay, so let's start it. So in the binary search we always divide our input in half. So that's why we'll have one integer called mid, then we will have left is equal to the starting of the array, and we'll have right, which will be the end of array, and we'll do this while left is less than or equal to right. So if you have seen my previous video, I was explaining two pointer solutions. So again, this one is two pointer solution. We are using left and right two pointers, and we'll run this um, algorithm until uh, left and right meets. Okay, so let's initialize mid. So for that we need to find the the mid element of the array. So the idea is, suppose this is the input. So, and the key concept is this input is sorted. So if we check whether the mid element here, 3 and 5 we can consider both, but we can take 3 here. So we can check our target element is greater than 3. It means our target element will be in right side of the array, or can be in the right side of the array. And Now when we go here, we have two elements, and let's say the mid element will be the 5. So we can check with the mid element. If it's the target one, we can just return it, and if it's not the target one, we can again divide it in two parts. Okay, so that's the gist of the algorithm. So first let's find the mid element, which is left plus right minus left divide by 2. So it will be let's say we have 1 2 3 4 5 6 7 8. Let's say this is the input. Then let's take odd input. I think that would be easier. Then in that case, what will be left is equal to 0, right is equal to 8, because it is starting from 0, and length is 9, 9 minus 1, which will be 8. And mid element will be mid element, which will be 0 plus 8 minus 0 divided by 2, which will be 4. So our mid element will be 5, because it is 0 based array, so 5 will be our mid element. And let's say in this case our target is 9, then we know that our target is greater than mid element. In that case, we will consider 6 7 8 9 is our input and do this process again. So our input will be 6 7 8 9. Our left is equal to 5, because again it's 0 based array, and right is equal to 8, and mid is equal to 5 plus 8 minus 5 divided by 2, which will be 5 plus 8 minus 5 is 3, and if we divide it by 2, it will be 1.5, but because we are taking it as integer, it will take as 1, and the mid will be 6. So our mid will be 6, so our mid will be here 7. And again we know that 9 is greater than 7, then we can do this again, taking 8 9 as our input, and that's how we go ahead until mid is 9, and we can return its index. Okay, so we found the mid element. Now if numbers of mid is equal to target, then we can return mid. If target is less than numbers of mid, then we'll just change our right index to mid minus 1, right pointer to mid minus 1, and cite it in curly braces, and else left is equal to mid plus 1. Otherwise we'll increment our left pointer, and at the end, outside the while loop, we'll return left. Let's try running it. Okay, so it got expected solution or answer. Yeah, okay, let's try submitting it. Okay, so this is simple binary search algorithm. There are many other algorithms, but I think this is the famous one. That's that's it for today's video. If you have any questions, comments, please put it in the comments. If you have better solution or better way to do it, let me know. Yeah. See you in the next video.